Hi folks, in this video we're going to take a look at decomposition reactions, and they're essentially the opposite of a synthesis reaction. So last time we saw synthesis reactions had two or more elements or compounds as reactants, and they yielded one single product. So this goes in the opposite direction. This is a reaction with a single compound as a reactant, and it breaks down into two or more products. Okay? So similar to before, here though the products could be elements or compounds, but it's the reactant that's always going to be a compound. Okay? Now because you have just one reactant, usually compounds don't just spontaneously decompose into two other types of particles. So here there's usually some sort of energy involved, so like heat, light, or electricity that causes this compound to break down. And since again we're going to be using chemical equations to represent these types of reactions, please make sure it's balanced before you move on. Okay, so let's start with example 1. So here it says, in the presence of heat, calcium carbonate breaks down to yield calcium oxide and carbon dioxide. So here this fits the bill for decomposition because you're starting with one reactant and then it breaks down to produce, in this case here, two products. So these are all chemical formulas that you should be able to write. So I'm going to ask you to turn off the video right now and spend some time trying to solve this problem. Okay, we're back. Let's take a look at the solution to this problem here. So we start off with calcium carbonate. So we see calcium's a metal, and carbonate, because of the ATE, this should make you think of polyatomic ions. So let's take our chart for polyatomic ions, and we see that carbonate indeed is a polyatomic ion. So it's CO3, and it has a charge of -2. Okay, and while we're at it, let's check calcium. Calcium's got a charge of +2. Okay. Okay, so here calcium has +2, and carbonate, which is CO3, has -2. Now because they have the same charge, you only need one of each to get a neutral compound. Okay, so on the left as a reactant we have calcium carbonate. Okay, only one of each. Notice I don't put brackets around the polyatomic ion since I'm only taking one of them. Okay, and now this produces calcium oxide. Now here we see IDE at the end, so this tells me that there's no polyatomic ion. So calcium, again, metal, oxygen, non-metal, so another ionic compound. So we already know calcium is +2. So let's check oxygen, although we really should know this one because we use it so often, and we say that oxygen is -2. Okay. So again, we only need one of each to get our neutral compound. So calcium oxide. Okay. Plus, and now carbon dioxide with two nonmetals, and we see our prefix di tells us that this is a molecular compound. So here, plus carbon, only one of them, dioxide, so O2. Okay, so now we've got our skeleton equation. So again, we've got our one reactant, which produces two products. Okay, so let's go ahead and balance this here. So I look at the calciums, the metals, calcium 1, so they're already balanced. Let's look at the carbons, one carbon on the left, one carbon on the right, so already balanced. And when we look at the oxygens, 3 on the left, and 1 + 2, 3 on the right. So this, in fact, is already balanced, but make sure you're checking. Okay, let's take a look at example 2. Okay, this says when exposed to sunlight, silver chloride yields silver and chlorine. Okay, so again, decomposition because you've got one reactant and two products. Okay, so again, these are all chemical formulas you should be able to write. So I'm going to ask you to stop the video and work on this for a couple of minutes. Okay, so we're back again, and so here on the left, silver chloride. So again, metal, non-metal, IDE at the end, so no polyatomic ion. So let's figure out what the chemical formula is going to be. So here we see silver. There we go, silver +1, okay, and then chlorine, okay, -1. So if we have silver chloride, okay, well, we only need one of each because the charges are 1 and minus 1. So AgCl, okay, and now our products are going to be silver, so on its own, Ag, plus, and let's keep in mind, as we've seen before a few times, chlorine is one of those diatomic molecules. It doesn't exist as just Cl, it exists as Cl2. Okay, so you have to recognize that. So now we've got our skeleton equation. So again, let's balance. I notice here 2 Cl's on the right, only 1 on the left. So I have to put a coefficient of 2. And then here now I've got 2 silvers and only 1 on the right. So a coefficient of 2 here to make this work out. Okay, let's move on to the last one. We'll do this one together here. So here we have, similar to example 3 in the previous video, we notice that there's information missing. So it says write a decomposition equation for gold 3 chloride. Okay, so they're only giving us one compound. So that tells us that this is our reactant, our one compound on the left. And we're going to have to figure out, take a guess at what the products would be here. So let's start by finding a formula for gold 3 chloride. So not surprisingly, since I see that Roman numeral, I should expect to find that gold is indeed a multivalent metal. So two possible charges, but they tell us that it's gold 3, so I know it has to be +3. And then we've got, what's the other one? Chloride. So again, we saw that before. Chlorine has a charge, or its ion has a charge of -1. Okay, so here we have +3 and -1. So in order to get my neutral particle, I'm going to need 3 chlorides to get -3. Okay, so my reactant on the left is going to be gold. I only need 1 and 3 chlorines. Okay, now we have to try to figure out what the products are going to be. But since this was an ionic compound made up of these 2 types of particles, it would make sense that my products are going to be gold on its own plus chlorine on its own. But again, as we saw just before, chlorine doesn't exist as a single atom. It exists as a diatomic molecule. So you have to recognize that you need to use Cl2. Okay? And so now we've got our skeleton equation with our 1 reactant, 2 products. Let's now balance this out. Okay, so the golds are already balanced out, but the chlorines are not. So let's balance the chlorines, and we see here that we've got 3 and 2. So we're going to have to somehow get to the lowest common multiple, which is 6. So if I put a coefficient of 2 here, that gives me 6 chlorines on the left, and that means I'm going to need a coefficient of 3 for 6 chlorines on the right. Okay, but now I've got 2 golds on the left and only 1 on the right, so I'm going to have to add a coefficient of 2 in order to balance this out. Okay, and here we have our balanced equation. Okay, so to just recap, you have synthesis and decomposition reactions, which are opposites to each other. Okay, and you want to make sure that when you're writing these chemical equations that you're always balancing.